In this video, I'm going to find the arc length for a parametric curve. Our parametric curve is defined by x is equal to cosine of t and y is equal to sine of t between 0 and 2 pi. As you probably already know, this is nothing but the unit circle, right? So we want to find the circumference of the unit circle. Now, the length of an arc in parametric world is defined by L is equal to integral a to b square root of dx over dt whole square plus dy over dt whole square dt. So we are going to integrate with respect to t from a to b of the square root of dx over dt square plus dy over dt square. Now let's go ahead and find this. This is pretty straightforward. And we know that circumference of a circle is 2 pi times r. In our case, r is 1, so we expect the answer to be just 2 pi, right? So let's go ahead and do that and check it basically. So integral, my t goes from 0 to 2 pi. So integral 0 to 2 pi square root of dx over dt. So what is the derivative of x with respect to t? So it's going to be negative sine of t, and I need to square it. Then plus dy over dt. What is the derivative of sine of t with respect to t? That's nothing but cosine of t. And then I need to square it. And the integration is done with respect to t. Now this is going to be integral 0 to 2 pi square root of sine square of t plus cosine square of t dt. Make sure that dt is outside the square root. Now if I simplify it further, my L is going to be integral 0 to 2 pi, okay, square root of sine square t plus cosine square of t is just 1. Since sine square t plus cosine square t is 1, so that's just going to give me dt, which is going to be t evaluated from 0 to 2 pi, which is going to be 2 pi minus 0. That is nothing but 2 pi as expected right here. So this is pretty straightforward and simple example. I hope that this discussion was helpful. Thank you very much.